Chapter 9 Review. Question number 1. You're given the equation y equals x minus 2 raised to the third power. What's the parent function? So because it's being raised to third power, we know the parent function is going to be y equals x cubed. It's a cubic function. And what kind of transformation do you see here? Because x minus 2, so this 2 is operating with the x, it's inside the parentheses, and it is the being raised to third power at the same time. So this is telling us the function is moving right 2 unit because 2 is a positive number. So move right 2 unit. So you can see that the point of origin went from 0, 0 to 2, 0. And then start from here, you do your count. Right 1 up 1, right 2 up 8, left 1 down 1, left 2 down 8. Number 2. Y equals x plus 1 squared minus 2. So first thing I will need to rewrite the equations to make it into the form of x minus. So you always have to set your equation into the form of x minus. And in order for me to get the same result, plus 1, I have to do it as x minus negative 1. X minus negative 1 is the same as x plus 1. So that means that my function is moving left 1 unit, down 2. The transformation information is going to be left 1 down 2. And because it's a quadratic equation, so the parent function is y equals x squared. So our point of origin went from 0, 0 to negative 1, negative 2. Y equals the absolute value of x minus 2 minus 4. What's the parent function? When you see 2 bar across the variables, the parent function is the absolute value functions. And to your mind at this point, you should have, because it's an absolute value functions, the shape of the graph is going to be the distinctive V shape. What kind of transformation do you see there? X minus 2, so minus 2 is inside the absolute value functions with the x, so this is telling us the function is moving right 2 unit. Negative 4 is the standalone number, it's outside of the absolute value function sign, so this is telling us move down. So our vertex point would move from 0, 0 to right 2, down 4. 4. Y equals the square root of x plus 2 plus 1. What's the parent function? It's radical expression square root. So our parent function is going to be y equals the square root of x. What kind of transformation do you see? X plus 2. So plus 2 is inside the square root function with the x. And you have to transform it into x minus negative 2. So x subtracting a negative 2 means that move everything left 2 unit. Plus 1 is outside, so moving everything up 1. So our original point would move from 0, 0 to negative 2, 1. 4. Piecewise functions. The dividing line given here is x equals 0, which is our y-axis. X equals 0, so I mark down directly x equals 0, the y-axis. So something's going to change from the left-hand side to the right-hand side across this line. So I have 2x minus 1 to the left, that's here. I have 3 minus x to the right. With this information, you can graph the function. Question number 6. The dividing line here again is x equals negative 1. So first put down the x equals negative 1 so that you know something's going to change. And to the left, I have a linear equation, 2x plus 1. To the right, I have a quadratic, x squared minus 2. Number 7. This time, you have two dividing lines, x equals negative 3 and x equals 1. So make sure you put down these two lines as your first step, x equal to negative 3, x equal to negative 1. And to the far left, we have a linear equation, x plus 4. In the middle, it's a constant value, x equals 5, so it's a horizontal line. To the right, it's a linear equation, so it's 2x minus 1. Question number 8. The composite functions that we just reviewed on Friday. You're given the function f of x equals 2x minus 1, g of x equals x squared minus 1. So first, letter A, how do I calculate f of g of 2? So again, when you do the composite function, make sure you work from the innermost function first. So g of function is inside, so I'll start with g of 2. I'm going to plug it in 2 to 2g functions. 2 raised to the second power minus 1. So that is 4. 4 minus 1, I have 3. And then followed by, I'm going to plug it into f functions. So 2 times 3 minus 1, which is 5. Letter B, g of negative 3 would be negative 3 squared minus 1. So I have 8. F of 8 equals 2 times 8 minus 1, which is 15. Letter C, g of f of negative 2. So this time your f function is inside, so you will have to evaluate f function first. Negative 2, plug it into the f function, which is 2 times negative 2 minus 1. And I have negative 4 minus 1, which is negative 5. Negative 5, plug it into g function, negative 5 squared minus 1, which is 24. Letter D, g of f of negative 3. Again, f is inside, so you will have to evaluate f function first. F equal to negative 3, 2 times negative 3 minus 1. So that gives us negative 7. G of negative 7 means negative 7 raised to the second power minus 1. And that is 48. Question number 9. You are given two functions, f of x, g of x. First letter A, you are asked to add them together. So how would I do this problem? I will simply take f of x plus g of x. Collect like terms, if there's any, and that's it. Second one, f minus g of x. So don't forget you are subtracting a function, so the second function gets subtracted. Everything gets subtracted. Whenever it's being subtracted, I ask you to put a parenthesis so that you do not mix up the symbols, the operations. So make sure you put a parenthesis over it as you distribute. Every terms in the second parenthesis get subtracted, and then collect like terms. Number 9. C, you're going to multiply the two function f times g. So this is the regular polynomial multiplications that we discussed back in chapter 5. So all you have to do is follow the arrows. So the best way to do this type of question is just to follow your arrows. Make sure every term in the first parenthesis get distributed to the second parenthesis. So x squared times x, I have x cubed. X squared times 1, I have x squared. Negative 2x times x, that's negative 2x squared. Negative 2x times 1, that's negative 2x. Negative 3 times x, that's negative 3x. Negative 3 times positive 1, that's negative 3. Collect like terms if there's any. So I have x cubed minus x squared minus 5x minus 3. Letter D, dividing. So f of x divided by g of x. So all I have to do is put my g, f on top, g at bottom. And since my f function is a quadratic, the top is a quadratic, I'll try to factor it. So I can factor into x minus 3 times x plus 1. And at the denominator, I have x plus 1. So I can reduce them. And everything reduced down to x minus 3. And in particular, you have to exclude the x value. That makes your denominator equal to 0, which is x cannot be negative 1 at all times. Number 10, you're given a graph. The graph looks like an opening down parabola. So the parent function is going to be y equals x squared. And what kind of transformation do you see? The vertex is being moved from 0, 0 to left 2, up 6, and then reflected. Don't forget it's reflected. So how do I write out the equation? Then the parent function is going to be, then the original function to this graph should be y equals negative x plus 2 squared plus 6. 7. The graph looked like a stretched S, so you should associate the function with the cubic x raised to the third power. Transformation, the point of origin went from 0, 0, now it's at 2, 1. So everything is being moved up, right 2, up 1, and don't forget it's being reflected. The graph went from left up, right down, so it's reflected. The function itself is going to be y equals negative. So reflected, negative x minus 2 raised to the third power plus 1. So right 2, up 1. Number 12, this is the square root functions, and what kind of transformation do you see? So the point of origin went from 0, 0, now it's located at negative 3, negative 2. So the transformation we see here is left 3, down 2, and it's reflected across the x-axis. So the function itself is going to be y equals negative square root of x plus 3 minus 2. Question number 13. This looks like the distinctive V shape we have. So the parent function is going to be absolute value functions. And the vertex, as you can see, it went from 0, 0 to right 3, up 4. And again, it's reflected. We were expecting to be an upside V instead of downside, opening down V. So the transformation we see here is right 3, up 4, then reflected across the x-axis. So the function itself is going to be y equals negative, don't forget reflected, so it's negative the absolute value of x minus 3 plus 4. Question number 14. There are two branches to this graph, and the most distinctive way to recognize the rational equations here, y equals 1 over x, would be putting down your horizontal and vertical asymptote. So the original point went from 0, 0 being moved to right 2, up 3. That's the transformation. So the function itself is going to be y equals 1 over x minus 2 plus 3. Number 15, it looks like an exponential functions, and the base you will have to check it. So I'm using the point, the y-intercept point and the second point, which is when x equal 1. So I use these 2 points, y-intercept point and when x equal to 1 to check my base, and it turns out to be the base is going to be 3. So the parent function of this graph is going to be y equals 3 raised to the x power. That's the exponential functions. The transformation I see, because I was expecting to see the x-axis as my horizontal asymptote, it went from the x-axis, y equals 0, down to y equal negative 4. So I know everything is being moved down by 4 units. So the equation itself is going to be y equals 3 raised to the x power minus 4. Question number 16. You're given a graph, it looks like a piecewise function. So first thing I would put down, when x equal to negative 2, something changed there. So the dividing line between the two functions is x equal to negative 2. To the left, we have a linear equation, and you can figure it out using the point slope form or the y-intercept format to figure out that the left-hand side linear equation is going to be y equals x plus 2. To the right, it's a parabola shape. It's an opening down parabola shape, and I see the vertex went from 0 to 4. So the parabola equation is going to be y equals negative x squared plus 4. Dividing line is x equal to negative 2. Last question. Again, the piecewise functions dividing line is x equal to 2. So I put down x equal to 2. To the left, it's a linear equation. From the graph, we can write out using the y-intercept form, y equals negative 2x minus 1. The y-intercept point is negative 1. So y equals negative 2x minus 1. To the right, it's a square root functions, and I see the point of origin went from 0, 0 to right 2, down 3. So the equation to this quadratic equation, square root functions, the square root function is going to be y equals the square root of x minus 2 minus 3.